Section 6.4 is on compositions, and compositions are when we apply more than one transformation to an image. So it's like you're reflecting and you're translating the image. And then you are still going to be keeping the same size for the shape. That's not going to be changing. Our first vocabulary word is a glided reflection, and this is when we translate an object and then we reflect it. And we all go in that order. And like we've already talked about, the composition of transformations is more than one transformation being done to an object. Okay. So our first example, the vertices of triangle ABC are A, B, and C. We are going, to find the image of triangle ABC after the glided transformation. So whenever you are given a list of transformations, you're always going to go in the order that they give them to you. Otherwise, your answer could be wrong because you did them out of order. So our first one is a translation. And remember, this is our rule for the translation. If it's adding or subtracting with the X, that tells us to go left or right. If it's adding or subtracting with the Y's, then it's going to tell us to go up or down. So for this one, we're subtracting 8, so that means we're going to go left 8. And we're going to go up 0 because nothing is being added or subtracted to the Y. So before we can do that, we first need to plot our 3 points. So on your notes, go ahead and plot these points. And don't forget to label them. And see right over there. And then once you have those points plotted, you can draw in your shape. And we're going to perform the transformation or the translation. So this one we're going left 8. So every point I'm going to move 8 to the left. And remember, when you label these ones, you're going to label them as primes. So A prime. And then we have B prime. And then we would have C prime. And then again, we'll connect our shape. So then the part that makes this a composition is that we also have a reflection in the x-axis. So we know the x-axis is this one that's horizontal. So we count how many spaces each point is above the axis, like A prime is 1, and then we would plot the A prime prime 1 below the x-axis. B would be 3 spaces above, so we're going to go 3 spaces below for B double prime. And C is 2 above, which means that C double prime would go 2 below. So then this would be our final answer in quadrant 3. And then we have our reflection review. Remember, with our reflections, we do have our rules. And when you're filling these out, there's 2 that have X, Y, and they're right across from each other. And then there's 2 that are Y, X. And the rules that you can, or the phrase that you can use is none, first, both, second. So in this first quadrant, there are none that are negative. In the second one, the first one is negative. In the third one, they're both negative. And then the second one is negative. So it goes none, first, both, second. So that rule might come in handy on our next example. So this one we're given a segment of CD with that C -2, 6. And D is at -1, 3. So there's our segment. And we are going to reflect this over the y-axis first. So this is our y-axis. C is 2 spaces away from it on the left. So we're going to go 2 spaces to the right, and that's where C prime is going to go. D is 1 space away, so we're going to go 1 space to the right, and that's where D prime would be. So now we are going to do a rotation. This one is going to be 90 degrees about the origin. It doesn't give us a direction, so we're going counterclockwise. Okay. So this one is in the first quadrant, so we are going to be using the X and the Y's. And we're rotating at 90 degrees, so we need to go once. So we are going to negative y, x for our coordinates. Point C prime has the coordinate point of 2, 3, 4, 5, 6. And D prime has the coordinate point 1, 3. So we're going to go ahead and reflect those. We have our x and our y. So negative y is going to become negative 6, 2. And that is where C double prime is going to go. So 1, 2, 3, 4, 5, 6, 1, 2. Go ahead and we can plot that point. Same thing for D double prime. We'll do negative y, so negative 3, comma 1. And that will be D double prime. And there is our composition. So we'll go ahead. And because we're doing the notes, we're going to skip this, be an in-class activity. We're talking about parallel lines now. The distance from point C to line R is 1. So we're going to label that here. So this has the length of 1. And point D to line R is 3. So we know that is 3. D double prime to line S is 2, and point C double prime to line S is 4. So we have 4 there. And we're going to find the distance between the parallel lines. And this is a double reflection. So DC was reflected over line R, and then D prime C prime was reflected over line S. So because we know that it was reflected here first, this distance is going to be the same. So we know this one's 3. And then the shape was reflected again. So we know that this distance is going to be the same as this one. So that makes it 2. And we're looking for the distance between the parallel lines. So we'll add those two numbers together. 3 plus 2. So the distance would be equal to 5. All right. And the last type of problem we're going to go through, example 4. After the double reflection in the image below, we're going to calculate the angle of rotation between these two triangles. So to find the angle of rotation, you're going to take the interior angle and you're going to multiply it by 2. So this one we would take 60 times 2. So the entire angle of rotation is going to be 120 degrees. And that's it for this type of problem. So our next example, why don't you try it and then hit play when you have your answer. For this one, you would have taken 68 times 2. And let's see, that would be 136 degrees would be your final answer. So that's everything for this section of notes. And you can go ahead and do the homework now. And if you have any questions, let me know.